Welcome to lesson 65, prime and composite numbers. Before we get into these two different types of numbers that you need to know, let's remind you what factors are. Factors are numbers that can go into a number perfectly. So what are the factors of 24? You'll notice that these numbers have a set, a pair. Okay? 1 can go into 24 perfectly, and it can go in 24 times. Those are factors of 24. What else is a factor of 24? Well, 2 can go in 12 times, and 3 can go in 8 times, and 4 can go in 6 times. 5 does not fit perfectly. It's not a factor. 6 is right there. 7 doesn't fit perfectly. 8 is right there. 9 doesn't fit perfectly. 10 doesn't fit. 11 does not fit, and 12 does. Once you hit the halfway mark of the number, the 2, if it's an even number, then you're done there, as long as you have the bookend of the whole number on the end. Anyway, those are the factors of 24. Now, a number that is prime only has 2 factors. Does 24 have more than 2? Yeah, it has a lot, right? So 24 is composite. Composite numbers have more than 2 factors. Prime numbers only have 2 factors. And you'll notice that they're always 1 and itself. So for example, the number 2 has a factor of 1 and it has a factor of 2, and that's it. So it's prime. 3 only can have a 1 and a 3. 4 is composite because it could have a 1 and a 4, oh, but also a 2. 3 numbers, and it's now composite. 5, only a 1 and a 5. 7, only a 1 and a 7. 11, only 1 and 11. 13, only 1 and 13. Those are all prime numbers. Now one number is a little tricky, because what goes into 1? Well, 1 does. Now based on the rule that prime numbers have a factor of 1 in itself, it's kind of following that. It's got the 1 number as 1, and itself is 1, but it does not have 2 factors. So 1 is not prime, and it's not composite. So if a book ever asks you, is number 1 prime or composite? It's neither. It is not prime or composite. The other thing I want to show you is that these numbers often can be written as an array, A-R-R-A-Y, and that's a series of X's, the letter X, that can be plotted out so you can visually see the numbers. So for example, the number 6 has a 1, 2, 3, and a 6 as a factor, right? And they're pairs. So 1 times 6 makes 6. 1 row of 6 X's makes 6. 2 times 3 would be 2 rows of 3 X's. But it still has 6, right? So this is 2 by 3, and this is 1 by 6. So I know if there's 2 different arrays that I can make, it's got to be a composite number. Okay? 1 times 7, or 7, like I had up here earlier, only has 1 and 7, right? 1 row of 7 X's. And if I wanted to make it different somehow, I can't. I could make it 1 column, but it's still 1 column of 6. 1 column of 7. It's only going to be prime. It only has 1 array. So if you have a number like 24, like we did earlier, and you wanted to make arrays, you can make lots. You can make 1 row of 24, you can make 2 rows of 12, you can make 3 rows of 8, 4 rows of 6, and on and on. So if there's many arrays for a number, it's probably because it's composite. If you have any questions about prime and composite numbers, then I'd be glad to help. Thanks.